Picture this. It's 3 in the morning. You're camping deep in the wilderness. Pitch black. Complete silence. Then you hear it. Heavy breathing. Footsteps circling your tent. A 300-pound mountain lion, close enough to kill you in seconds. Your heart stops. But then, something unexpected happens. The predator walks away. Not aggressively, not cautiously with one last look. It simply leaves. Why would the most powerful hunter in North America abandon an easy meal? The answer involves hundreds of thousands of years of history, and it might change how you understand predators forever. For hundreds of thousands of years, humans and large predators have occupied the same landscapes. In some cases, humans hunted predators. They tracked them, they killed them, they eliminated threats to their camps. In other cases, humans avoided predators entirely. They migrated. They learned which territories to keep clear of. In still other cases, predators won. Humans were hunted. The outcome wasn't predetermined. Of course, this wasn't true everywhere. Different continents, different climates, and different ecosystems produced different outcomes. The selection pressures weren't uniform. But in many regions, particularly in Africa, where humans and large predators coexisted most intensively, a pattern emerged across thousands of generations. Predators that were cautious around human encampments had higher survival rates. Predators that were bold or excessively curious, many didn't survive to reproduce. What happened wasn't evolution learning anything. Natural selection operated on a simple mathematics. Cautious animals reproduced more often, while bold animals died more often. Over hundreds of thousands of years, that mathematics accumulated. Evolutionary biologists consider this one plausible explanation, among several, for why many of today's predators show innate caution around humans. Other factors worked alongside it: learned behavior, human persecution, local ecology, and individual variation all contributed to shaping modern predator behavior. But the combined effect in many populations shows a consistent pattern. Predators in regions with intense historical human pressure demonstrate measurable behavioral differences, suggesting that multiple evolutionary and ecological processes have influenced how they respond to people today. Here's the critical question. Why humans specifically? After all, lions and hyenas compete with each other daily. Why don't predators fear each other the way they fear humans? The answer lies in what humans uniquely possess. Humans cooperate. We organize across large groups. We plan hunts weeks in advance. We track prey persistently, not for minutes, but for days. Humans invented weapons that kill from a distance. An animal doesn't need to understand spears to recognize that getting close to humans is dangerous. Humans control fire. For millions of years, animals have encountered fire in nature. But human-controlled fire is different. It's continuous, it's predictable, and it's consistently associated with organized human presence. Humans also pursue prey beyond exhaustion. A wolf tires after a chase. A human walks for hours. Most importantly, humans retaliate collectively. When a predator kills one human, the entire group mobilizes. Humans track that animal. They organize. They hunt it down. No other known predator combines large-scale cooperation, long-term planning, advanced weapons, controlled fire, and collective retaliation in the way humans do. Over hundreds of thousands of years, predators that survived were the ones that responded to these unique threats. Lions don't fear other lions the way they fear humans because lions don't face the coordinated, persistent, organized pressure that humans apply. In 2017, researchers began investigating a specific question: what actually frightens wild predators? They worked in protected reserves across Africa, places where lions, leopards, and hyenas actively hunt. They set up speakers near water holes where predators regularly came to drink. Then, they conducted controlled experiments playing different sounds: lion roars, elephant calls, frog croaks, and finally, human conversation. People simply talking. The results were striking. When predators heard human speech, they fled in approximately 83% of cases. Most left immediately. When they heard lion roars, sounds from apex competitors that could kill them, most predators showed minimal response. Why? Researchers proposed several explanations: historical learning, contemporary learning, or evolved risk assessment. Most likely, all three mechanisms work together in varying degrees. The pattern holds across multiple ecosystems. However, it's important to be precise. These observations came from specific predator populations in specific regions. The patterns are especially strong in Africa and parts of North America, while predator responses can differ in other parts of the world. Here's something equally interesting, but less often discussed. Humans smell fundamentally different from any animal a predator encounters naturally. Campfire smoke, synthetic fabrics, soaps, sunscreen, coffee. This chemical profile simply doesn't exist in nature. When a predator encounters this unusual mixture, its nervous system registers something novel. In the wild, unfamiliar scents often signal unpredictable risk. The safest strategy is frequently the simplest: investigate cautiously or don't investigate at all. Many predators choose avoidance. But this isn't universal. Not all species respond the same way. Hyenas tend to be more curious, while leopards are typically more cautious. Individual personality also plays a role. The overall pattern is strong, but it is not absolute. So we've discussed voice, we've discussed smell, we've discussed evolutionary history. These are documented deterrents. But here's the question that matters. If these factors are so powerful, why do any attacks happen at all? What changes when the system fails? When a predator encounters a tent, it faces something its nervous system may not readily categorize: an unfamiliar structure. Solid, stationary, not prey-shaped. Large carnivores hunt using search images, mental patterns for what prey looks like, moves like, and behaves like. A tent matches none of these patterns. What happens next is where science becomes honest about uncertainty. Some researchers suggest the visual mismatch creates hesitation. The predator can't reconcile its hunting instincts with what it observes. But we should acknowledge that the exact mechanism remains incompletely understood. What we can confirm is that documented attacks on people sleeping inside tents are extremely rare. The precise reasons why remain only partially understood, making this one of the most intriguing unanswered questions in predator behavior research. Most wild animals avoid fire, but let's be precise about what we actually know. Wildfires have existed for hundreds of millions of years, so animals have encountered fire naturally for eons. What's different is human-controlled fire, a campfire that is controlled, predictable, and consistently signals human presence. Why animals avoid it is likely explained by multiple factors. Heat is physically aversive. Bright light disrupts night vision. Flickering movement can be startling. Over thousands of years, many animals may also have learned that human fire predicts nearby humans, and where humans are present, danger often follows. The honest scientific answer is that several mechanisms probably work together, and researchers still don't fully understand every detail. What we do know is that campfires generally increase the distance predators maintain from campsites. Understanding this required decades of independent research across multiple continents. Researchers fitted wild predators with GPS collars, tracking their movements continuously for months or even years. These long-term records revealed where predators traveled, where they hunted, and which areas they consistently avoided. Acoustic sensors were also deployed to record animal vocalizations and monitor behavioral changes in response to nearby human activity. Controlled experiments, such as the voice study, isolated individual variables under carefully designed conditions, allowing scientists to compare predator responses to different sounds. At the same time, ranger observations were systematically recorded. Thousands of encounters between humans and predators were compiled, analyzed, and compared to identify recurring statistical patterns. Each study answered only a small part of the larger question.
This wasn't a single experiment proving one grand theory. It was hundreds of researchers working across multiple institutions and several decades, gradually assembling evidence from many independent sources. That's how science usually progresses. Scientific understanding grows incrementally. Individual studies sometimes disagree or produce conflicting results, but as evidence accumulates, broader patterns begin to emerge. Those patterns are constantly refined as new data becomes available.
Under what specific conditions does predator avoidance fail? The first is desperation. Imagine a leopard suffering from severe dental decay. It can no longer catch healthy, agile prey. Suddenly, a sleeping human inside a tent may appear to be a possible target. Research tracking injured and starving predators has found correlations between physical impairment, food scarcity, and increased conflict with humans. Although these situations are uncommon, they help explain why some attacks occur, despite the general tendency toward avoidance. The second exception is habituation. A bear discovers garbage at an unsecured campsite. The food is easy to obtain, and no immediate threat follows. The bear returns again and again. Each successful visit reinforces a new association. Humans mean food instead of danger. Over time, learning can weaken inherited caution. Park authorities have documented individual bears whose behavior changed across repeated encounters, demonstrating how habituation intensifies when animals are repeatedly rewarded. This is why proper food storage is one of the most important safety practices in bear country. The third exception is territorial overlap. If you sleep on a crocodile beach or camp inside an active hunting area at night, the normal ecology of fear may no longer apply. In that situation, you've entered the predator's territory during the time when it naturally expects to hunt. Consider this scenario. A leopard approaches a waterhole at dusk. It's thirsty, and its hunt has been unsuccessful for 2 days. Then, it hears human voices nearby. Multiple voices, unpredictable sounds. The leopard freezes. For several seconds, nothing moves. Then, it turns around. It walks away from the water. It walks away from its own territory. It abandons something it genuinely needs because, from the animal's perspective, the potential danger now outweighs the potential reward. It's not that the leopard consciously reasons through the situation or deliberately weighs every option. The process is much simpler and far more fundamental. Its nervous system rapidly processes unfamiliar sounds, unusual activity, and unpredictable behavior to produce an immediate assessment of risk. The conclusion is straightforward: leave. That single decision is the product of countless interactions between predators and humans over hundreds of thousands of years. Whether shaped by evolution, learning, or both, the result is a behavior that often favors caution over confrontation. Let's be precise about what science has established. We know that predators display avoidance behaviors around human settlements in many documented cases. Human voices can trigger flight responses in certain predator populations under specific conditions. And habituation, the gradual loss of fear through repeated exposure to food, is a well-documented and reproducible phenomenon. We also know that desperate, injured, or starving predators often behave differently from healthy individuals. Their normal patterns of caution can weaken when survival becomes more urgent than avoiding risk. At the same time, important questions remain unanswered. Scientists still don't fully understand why unfamiliar structures, such as tents, appear to discourage many predators. Nor do they know the exact balance between inherited evolutionary tendencies and learned experience across different populations. Researchers also cannot say with certainty that these patterns apply equally to every predator species or every ecosystem. The complete neurobiological processes that trigger avoidance remain only partially understood. Good science acknowledges both what is known and what is still uncertain.
Here's what we can say with confidence. Across many ecosystems, humans have profoundly influenced how numerous large predators assess risk. This effect is real, well-documented, and ecologically significant, but it is not the result of a single cause. Evolutionary selection in some populations, individual learning in others, habitat alteration, human persecution, and local ecological conditions all contribute to the behaviors we observe today. The story is far more complex than a simple narrative of dominance or fear.
It's not that humans completely conquered predators, nor that predators simply learned to fear us. Instead, two apex species gradually negotiated a shared landscape through conflict, adaptation, and countless generations of interaction. Usually, humans occupy certain spaces, and many predators choose to avoid them. When that balance breaks down, through desperation, habituation, or territorial overlap, the consequences can be severe. That's the real science, more complicated than a dramatic story, but ultimately far more honest. Think about what this actually means. The next time you hear a growl in the wilderness or watch an animal quietly retreat from your campsite, remember that you're probably not witnessing aggression. More often, you're watching an animal make a risk calculation. From the predator's perspective, the question isn't, can I win? It's, is this worth the risk? Usually, not always, but usually, the answer is no. That decision reflects countless generations of interactions between humans and large carnivores, shaped by both experience and evolution. You're not the prey in this story, but you're also not dominant because you're stronger, faster, or more powerful than every predator. Humans became significant because cooperation, planning, technology, and long-term interactions with the natural world gradually reshaped the relationship between our species and theirs. The result is an uneasy balance. Most of the time, predators avoid people whenever they reasonably can. When that balance holds, both species continue on their separate paths. When it fails, the consequences can be dangerous for animals and humans alike. What's the closest you've ever come to a wild predator? Share your story in the comments. I genuinely enjoy reading them. Every encounter is different, and real experiences often reveal just how complex the relationship between humans and wildlife can be. If you enjoy documentaries grounded in real science, not exaggerated, sensationalized, or oversimplified, but based on evidence and honest uncertainty, consider subscribing for more. There are still countless fascinating stories hidden within the natural world, and we'll continue exploring them together. Thanks for watching.